Good morning guys, I'm Chris and welcome back to this Sunday's episode of Rift Amps. I often get asked what is the difference between an amp designer and an amp builder. You might think they're the same things, but they certainly are not. A builder is simply doing paint by numbers, just copying and replicating what's already been done before. It's prescriptive, right? So let's say, take for example, you're building this Tweed champ, the 5F1, the most popular of all champs. It's a very common circuit that people like to build as home brews, as kit builds. It's very simple, it's very toneful, and you can do quite a lot with it in terms of understanding tone shaping, EQing, attenuation, gain control, all those sorts of things, right? But if you don't have a proper understanding of circuit design, which often beginner builders and kit builders and hobbyists don't, then it's easy to inadvertently copy design mistakes which you would be forgiven for assuming were correct or are correct. So we'll take the 5F1 for example, because I've now reached the point in my build queue where I've got to build one for a customer. I haven't built a 5F1 for a while, and every time I revisit a circuit, I like to just go through it and check things out and see if there's any improvements I can make in terms of tone, reliability, grounding, anything like that, anything that we can do to improve the amplifier in any way, shape or form. Because as you all know, my ethos is that every amplifier needs to be better than the last one that I build. In some way or some form, right? So I'm now going to start building a 5F1 for a customer. And so here's the classic 5F1 circuit. It is so simple. It's one of the simplest circuits out there, and we do like these circuits. Now, I'll quickly walk you through it. You've got your two inputs here, your high and your low input. Standard configuration, a 1 meg grid leak resistor. You've got your two 68K stoppers. So when you are in input number 1, your signal has 1 meg resistance to ground, or 1 meg impedance to ground, and then you have two 68Ks in parallel, giving you 34K of input grid stopper to the first stage. When you go to input 2, you now have 68K input stopper here, but you then have the other 68K and the 1 meg in series. No, you don't. Sorry, you have the what am I talking about? Ignore me. I'll explain that one again. When you're in input 2, the 1 meg is bypassed. This now forms a voltage divider. So input 2 sees a total of 136K to ground, but the grid is only stopped by 68K. So it looks I'm probably just going to draw this out exactly as it's shown on here. To grid from the input. So the input total to ground is 68K. God, I didn't write that well, did I? 68K, 68K. What is wrong with my writing today? So you combine those two together, that's the total impedance to ground, or resistance to ground, whichever way you want to look at it today. But the grid, the signal is only attenuated by one of those, and that's how you get the low impedance input on this one. When you're in one, as I said, you get both of these 68Ks in parallel with 1 meg to ground, and that's your high impedance input. Anyway, if I confuse you about that, sorry, I will explain these in a separate video in more detail. We then go into the first gain stage. It's a standard RC coupled gain stage. We've got an unbypassed cathode resistor, 1K5, 1500 ohms. Got a 100K plate resistor or anode resistor from our high voltage supply. And then we've got a 20 nanofarad, modern value being 22 nanofarad coupling cap up to the volume control, which forms the voltage divider again, feeding the next grid. Another unbypassed 1K5, tiny bit of negative feedback coming from the output transformer through a 22K resistor, and then we've got another coupling cap, another plate resistor there, grid leak resistor there, and into our 6v6. It's arguably the simplest design out there. 5x3 rectifier doing a high voltage. Okay, so I want to talk about grounding on a champ, because this is what I've spotted this morning, or I hadn't, or had yet to consider previously, just as I'm working through the design. Now, the rule of thumb and best practice is that each stage, each part of the amplifier grounds to the same coupling cap, sorry, the same filter cap to which it is supplied. So, for example, gain stage 1, V1A here, this grounding point here, this gain stage is powered from this filter cap here. So these should be grounded together at the same point. Okay. This one here is also fed from the same cap. So here's your plate resistor, here's the cap. So that should be grounded to that point there as well in your chassis. We look at the 6v6. The 6v6 is powered, the anode or the plate comes through the output transformer winding from this cap, and the screen comes from this cap, and the cathode, which is bypassed here. So these should all be grounded together, sorry. All right. So the 6v6 should ground to the filter caps to which it is from which it is supplied. You got that? Right, okay. Just broken my pencil. Remember that. The cathode resistor should, for best practice, be grounded to either the 16 or the 8 microfarad cap, the first two in the B plus rail. We look at the layout diagram for a 5F1 champ. Here's the 470 ohm resistor, here's the bypass cap. Why is it grounded to the preamp node? That's not right. That doesn't make sense. That's not best practice. That's not the way we do things. So if you were to build a 5F1 using the original layout as Fender did it, you know, for whatever the internet says is best tone or whatever, you are building in a mistake. Easiest way to fix it. Here's my board design. I'll zoom you in so you can probably see it better. All I've done is move my 6v6 cathode resistor and bypass cap from this point, see it was here, over to this side of the board. And that's it. And we are now preventing any ground loops and things like that. It's funny, isn't it? You know, I've been staring at 5F1 champ layouts for years. And sometimes even I didn't spot it. But there you go. So this is why you shouldn't just copy original designs, you know, and the way things are wired and laid out, because you might inadvertently be building in a mistake. So on this one, I'm just about to build the board this morning. I'm going to, I've changed the design slightly. So what I've done there, I've kept everything else the same, spaced everything else out. I've used the rest of the layout is fine, but you see all of my preamp stages are grounded to the preamp node, and this here will go up to the input jacks, and these will ground over to a dedicated point by the power transformer, not on a power transformer bolt, but by the power transformer. So yeah, I just wanted to show that to you. Sorry, that's 9 minutes and 39 seconds of me rambling about a built-in grounding mistake on a 5F1 champ. Can I get your advice, please? This is the 70 watt ultra linear distributed load super reverb, the one that I paid 200 quid for from Noisy Josh, the one that is very rusty, wasn't working, managed to get it up and running, but my original plan was to do a full restoration on it, not just a resurrection, but a full restoration. I wanted it to look like it had just come out of the factory fresh. So complete strip down, replate the chassis, make it look brand new from the chassis. I mean, it's just another silver panel 70s Fender, you know, it's not super rare, it's not super valuable, so why not see if we can do a full restoration on it. Problem is, it's been sat on the shelf now for a couple of months, and the more I stare at it, the more I keep thinking, maybe I should do something else with it. Maybe I should do something else with this amp. So, I'm stuck because I can't decide. I don't know what to do. I need some inspiration. So would you all please, in the comment section below, let me know what you think I should do with this. Really, we've got 3 options. The first option is the original plan, a full restoration, back to factory spec, make it look brand new. As I said, so I want it to look like the day it came out of the factory, you know, showroom piece, as it were. That's option 1. Option 2 is resto mod. So we do what you might call factory plus. So I do the same as that, but we tweak the circuit, we make some changes, we make some improvements to it. We not keep it perfectly factory spec, but we modify it in quite a tasteful way, I think is a nice way of putting it. Option 3 would be to do just the electrical restoration on it and keep it cosmetically as it is, including the rusty chassis, you know, like a road worn or relic thing. We could do that. So actually there is actually a 4th version, and a 4th version is that I just sell it. The 4th option is that I just sell it and somebody else can take on the work. So let me know down below what you think I should do with this, and if you think I should do modifications to it, let me know what sort of modifications I should be looking at. And I think if we do modifications like a resto mod, maybe we look at incorporating some different features and things to it that weren't available at the time. Maybe we get rid of the opto trem and put in like a brown panel tremolo circuit. That might be a fun thing to do. Maybe we look at harmonic tremolo. I don't know. I haven't decided. Maybe we modify keep one of the channels the same, or make that black panel. The other channel we do like a basement channel instead. There's so many options and so many things, but I can't decide. So please, in the comment section below, let me know what you think I should do. I'm pretty sure it's going to be a 50-50 split between restore it as it is, or restore it as it was, sorry, and modify it. So, but I want to get some inspiration and some ideas, because I just can't decide what to do with this amp. Guess what's back? The WEM copycat. Same issue as before. Well, same symptoms as before, in that we're still getting tape slip. Now, I'll turn it on and show you. The tape runs really slow, and then it will grab and go quick, and then it will slow down and grab quick, and so on, just as it was before. Now, I had perfectly set the tension on the tensioner with the spring, and all you need to do is just apply the tiniest pressure here, and it starts working properly again. Now, that's where I'd set it before, so the tensioner has failed, and I'm not sure why. It's probably the spring. Maybe I suspect that the spring is faulty, but I can slow it down, speed it up just with the tiniest thumb pressure. So we need to get back into this, open it back up, check that the tensioner spring is working properly as intended. If not, then I am going to have to replace the spring, I suspect. But never like a comeback. It's always annoying when it happens, but this is old gear, you know, stuff happens, and we'll look after the customer, make sure he gets a working piece of gear. The deluxe reverb reissue, still haven't got around to finishing off yet. I was waiting for some caps to come in. I had the F&Ts, but I didn't have the 220 microfarad at 100 volts. So I've got some Vichets. They've just turned up, which means I can now crack on with this, get this thing done, make the repairs inside. Got a new reverb tank for it as well, as I showed in the previous video. But this is the problem with the Easter weekend here in the UK, is that you lose the Friday and the Monday for bank holidays, so, or public holidays as the Americans will call it. So everything gets delayed, and you just end up waiting longer for stuff, which is a really difficult or annoying situation, especially when you've got customers who really want stuff back. So yeah, I can now crack on with this and get this thing done. This is one of the vintage AC10s that I look after. It's been on the channel recently. Customer is complaining that it's quite microphonic, so one of the valves is making all sorts of fun noises, which means we need to get inside and have a look. I've got a separate microphone inside the cabinet, so you are picking up extra noise than it's actually making, because I've increased the sensitivity. Usually with these things it's going to be the EF86, but we never assume, we need to check. So I need to get this back panel off. There you go, you can hear it. So there's something really sensitive going on inside. So let's get the back panel off, have a look inside and see what we can find. Okay, so rear panel is out. I've pulled the chassis forward and here's the EF86 in the front here. Got the ECF82 in the middle and an ECC83 on the end here. Now, EF86s are nearly always microphonic, so you have to take some of the noise they make with a pinch of salt, because it often, when you tap them, they might appear to be microphonic, but actually in circuit, they're fine. So a little bit there, but if I tap the ECF82, I think that's the problem child. Yeah, that's the problem, the ECF82. So we're going to have to see if we can find one, because they're not made new anymore, so it's going to have to be a vintage replacement. So I'm going to have to hopefully find one that performs well and is noise free. So wish me luck. I had a lot of questions or comments about the AC15 50th anniversary amp that's currently in for repair, and a lot of the questions were around, you know, why didn't the Vox R&D department design the thing properly? What were they thinking of? Did they not bother checking, you know, the how hot the output valves were running, all that kind of stuff? And the short answer is they did what the market demanded, which I know that sounds stupid and it sounds ridiculous, but it's what a lot of guitarists expect. So here's the schematic for the amp that we've got in repair, and here is a schematic for an original AC15, of which this amp is based on. So it's pretty much identical. So here's your EZ81 rectifier valve coming off your output transformer. We've got our first filter stage here, which originally feeds a 16 microfarad capacitor. Then we've got a 10 Henry choke, or 10 to 20 Henry choke, I should say, sorry. Then a second stage of filtering, and that's where all of the high voltage comes, is for the rest of the amp is fed from. And we've got the same thing here. So we're coming off the rectifier valve. We've got our first filter stage. This time it's 22 microfarads. So they did up the filtering slightly. We then go through our choke. Yes, it's only 8 Henry in the reissue, but the difference between 8 Henry and 10 Henry in this circuit is minimal. So don't worry about that. Then we've got our source point here where everything else is fed from. So copied that at the same point. They didn't make any other changes. If we then compare the output stages, try and get all of this in one shot for you. You can see our high voltage comes from our source point to the center tap of the output transformer. And on this side, our high voltage comes from our source point all the way down to the center tap of the output transformer. All right. Then from that point there, our screens are fed directly with 100 ohm screen stoppers, too small. But they're fed from this point. They're not fed from a point further downstream. The reissue amp obviously has got the pentode triode switch, so that's in circuit, and the triode mode takes its feed from the plate supply, as is usual. And as you've got going on there. So again, that's all identical. They've used the same value cathode bias resistor, 130 ohms in both amps. The original used a 50 microfarad cap. The reissue uses the E12 value, the modern E12 value, which is 47 microfarad. It's the same thing, right? And you can see the rest of it is identical. 1K5 grid stoppers, 220K grid leaks up here and here. It's the same thing. The cut control is the same. All right. They've just copied the amp as it was. Same voltages, same architecture, same layout. Now, from an engineering point of view, that's not good. That's not good at all. It's not good practice. It's not best design, etc., etc., etc. But from a marketing point of view, it's exactly what the customer wants, isn't it? I want a faithful recreation, you know, down of the amplifier down to everything, and I don't care if it's got mistakes. And actually, you know, this is the point I'm making with the 5F1 Champ build. If you just blindly copy everything because that's how the originals were, it's got to be good, right? Well, actually, no. We learn from these mistakes and we try and improve things. So, yeah, it's poorly done with the right intentions, I think, is the fairest way to put it. But you know, valves aren't cheap anymore. Things are highly stressed. We know now that if we cool things down and we set things up to run properly, the tone is better, the performance is better, and longevity is better as well. So anyway, I thought I'd show you the two schematics, and they're pretty much identical, apart from the modern features that have been added to the reissue. Although, you know, it's 2007, so what's that, 18 years old now? So is that still modern? Who knows? But there you go. Yeah, what would I do? And I think that's a fair question to ask. If I was building an AC15 clone, what would I do? Well, there are two schools of thoughts, right? One, we do want to keep our anode to cathode voltage relatively low. We don't want it to be too high, but we don't want to cook the valve. So I would see the two ways of cooling bias off, right? In a cathode bias amp. One is to increase the value of the cathode resistor, which I've shown you works, but as current drops, voltage increases, so our anode to cathode voltage therefore increases. So what I would do is have an output transformer, sorry, a power transformer wound to drive my rectifier valve with a lower voltage, so my output voltage is lower, so I can keep the original values, try and retain some of that squish factor, which people want, but run the output valves in a cooler spec. So if I was doing this amp, that's what I would do. And I'd try and find a nice compromise between the two that retains all the nice rich harmonics and touch response that these amps are known for, without forcing the customer to revalve the thing every 6 months. Well, that's it then, guys. Thank you very much for watching once again. Apologies, it's a bit of a shorter video. It's only a 3-day week for me here in the workshop. Obviously, I was closed on Monday for public holiday, and this on Friday. You're watching this on Sunday, but on Friday, I'm leaving to go racing, opening round of the championship. So really looking forward to that. Updates on that on next Wednesday's video. So yeah, wish me luck. There is going to be some bonus footage at the end of this video, final car prep and stuff. So if you want to watch that, please stick around. But it just leaves me to say, please give this video a thumbs up, or your comments and questions down below. Subscribe if you haven't already. Hit the notification bell in case I do put out any extra videos. If you're feeling super generous and you want to support me financially and support the channel financially, you can do so by joining the channel just like these guys have. And I will catch you all at the next one. Yeah, straight on that, mate, you're right. It's quite high up here. Say what? 60 mil.
Yeah, they came in and fitted it. $2,000 extra. Okay. It's up a bit of a dealership, so luckily it's not red, which is nice.
Oh, they don't be red?
Yeah. Because they wanted the front lights were the case and the thing was red.
Was it?
Yeah. So I was fucking well happy when it turned up and it was white. It's all the BMW ones obviously didn't want red on it, so it turned up white. So we're going to get the standards at some point out of it black because they're red as well, but I fuck my red is. I don't mind it, but in here I want it all less. That's why we've got the grey rounds.
Yeah. £10.5 grand. What's that?
Yeah, 650 kids still.
You rolling? In the green?
That's it.
Doesn't matter where.
Everyone's in green, back to straight. Well, a bit like saying, look at this green. No, too far.
Well, the wheels are straight.
No, too far to the right. Left. That's it. Yes.
So that wheel's not straight.
That's fine, we saw that. great. What was it before? Camber on the front?
3.
3?
Yeah.
No.